For this part 3, we're going to keep going and adding more properties. So I think the next one we're going to be using Pythagorean identity in this section. So again, we will be using still the reciprocal identities, the quotient identities, and now we're going to be using the Pythagorean identities. So what I want you to take away from this is that this 1 plus cotangent squared theta equals cosecant squared theta can be manipulated to be equal any of these functions by either adding or subtracting something. So like to get this one, all we did was subtract the 1 to the other side and we got this one. All we did here was basically flip-flop these. So now this became negative and now this is negative, that's positive, and so on. And it's basically true for all of these. So it's not that they're different equations you have to memorize. As long as you know these equations, you get all of this from this one by either adding or subtracting something. And that's basically it. This one should be, we have seen before in Math 2, and we actually saw it earlier this last week, I believe. These two you haven't seen, but we will be able to use these in this section to verify trig identities. So just like yesterday, I like to work with the left side. Not that you have to, but that's what I like to do. So I'm going to manipulate that tangent squared x plus 1 and the cosecant x squared minus 1 to something more simple, using our trig identities from technically the Pythagorean identities. I know that tangent squared x plus 1 is equal to secant, so that should be secant squared x. I know that cosecant squared x minus 1 is equal to cotangent. And again, that is from our trig identities that is in the worksheet and that we just kind of went over really quick. So hopefully you have your trig identity worksheet in front of you so you could really see it. But just in case you don't, we know that tangent squared x plus 1 is equal to secant squared x. So this is where this piece is equal to that piece, and I replaced it. We also know that cosecant squared x minus 1 is equal to cotangent squared x. So this piece right here is equal to that piece. So this piece replace that. And now I just need to manipulate it a little bit more, and I could separate it. I want you to notice that I already have a secant here, so I don't want to change that. But what I can do is leave that secant squared like it is, and then go times 1 over cotangent squared x, and then change this cotangent, change this cotangent into tangent squared, because I know, or we all know, that tangent squared x is the same thing as 1 over cotangent squared x, because it's the same thing as if you had tangent of x is equal to 1 over cotangent of x. It's the same thing. So now we're going to have secant squared x times tangent squared x, and we verified it, and that's our answer. So we're basically just using information that we know. Just because this is squared, that means that's squared. If it was cubed, then this is cubed. But we know that tangent of x is equal to 1 over cotangent of x, because this is one of our reciprocal identities. And just the power, we just replace that power. Right now, this is the power of 1. Now these are power 2s, and if it were power 3s, you keep going on and on. Okay, again, I'm going to work with the left side. One thing that I do want you to notice or understand is what I have. So I want you to see that I know this is tangent squared. There's a couple things I could do with that tangent squared. And one of the first things that I'm going to do is to change it to sine and cosine, because I want to get just a cosine squared. So I need things to cancel out, because I need to get rid of that 1 somehow, that negative, and the tangent, because all I need is cosine squared x. So I'm going to have 1 minus cosine squared x. That tangent, I know that tangent is going to be the same thing as sine squared x over cosine squared x. because we know that tangent of x is equal to sine of x over cosine of x. So if I just put an exponent here of 2, then all of these have an exponent of 2 also, or a power of 2. Okay, then now we have that these two things are being multiplied. This negative cosine squared x is being multiplied times that. This multiplication now allows it to cancel. So now we're going to be able to cancel these cosines. And now I'm going to have 1 minus sine squared of x. And we know that sine squared of x plus cosine squared of x is equal to 1. And since I have a 1 minus sine squared, now that means I can manipulate this one and think of it that I'm going 1 minus sine. All I did was subtract the sine squared to the right side. And now I know that, oh, look, cosine squared x is equal to this piece. So that means this becomes cosine squared of x, which is my identity on the right side. So I have verified it. All we're using is the identities and manipulating to what I want. So you have to keep looking at the left side and the right side to see what you have and what you need to get rid of. So since we are adding right here, we're going to need a common denominator, and they're not the same. This one has a minus sign, this has a plus sign. So we're going to be doing what we did on the previous part, which we're going to multiply the left side and the right side by what it needs. On this side, I'm going to need a 1 plus sine of x, and I'm literally going to multiply this to the top part and the bottom part. And on the right side, you need a 1 minus sine of theta not x. And I'm multiplying that to the left and the right. So that means my denominator is going to be 1 plus sine theta, 1 minus sine theta. And the top is going to be 1 plus sine theta plus the 1 minus sine theta, because all I did was go this number times this gave me this, that plus sign is that one, this one times this one gives me this, and my common denominator is basically these two being multiplied. The next thing I'm going to do is I need to secant of theta, so let's see what I could combine. These two combine and literally go away. Now I'm going to have the 2 over the 1 plus sine of theta over 1 minus sine theta. And since they're being multiplied, I'm going to say, and there's nothing here. It's something very simple. I'm going to distribute this. So I'm going to do the work on this side so you'll see it. So it's 1 plus sine theta times, that should be a parentheses, 1 minus sine theta. And it's just to distribute 1 times 1 is 1. 1 times that is negative sine theta. This one times that is positive sine theta. This one times that is going to be negative sine squared theta. These two are going to cancel away, and we're going to get 1 minus sine squared theta. So now we have 2 over 1 minus sine squared theta. And we know that 1 minus sine squared theta, that is equal to cosine squared theta. So now we have 2 over cosine squared theta. And if you really want to know, this is like if it was 2 times 1 over cosine squared theta. And we know that 1 over cosine squared theta is the same thing as secant squared theta, because those are their identities. And that's what we have and what we needed. So checks out. So it's just manipulating and figuring what we need to move and change. Okay, so I'm going to say that you write this problem down, and I want you to try it by yourself. And under the little box, the answer is there. I'll give you a couple minutes. I'll pause the video and then you try it. And then after that, I'll show the box, what's under the box, and explain it very quick. Same here. I want you to try this one, so write it down and then pause it. Once you are done working it out, then I say unpause and let's see what the answer was. So the answer is the following. What happened here was This secant x became 1 over cosine x, which is just one of our identities. This tangent of x became the sine of x over cosine of x, and that sine we left it. So if you notice, all of these, we change everything into sines and cosines and manipulate it using those. That's one of the best things to do. When in doubt, always work with sines and cosines. Then we had two separate parts, and they had a same common denominator. So since that we had a common denominator, now we just multiply the sine of x times that one and give us a sine x squared. Since we have a common denominator, we could actually put the two top parts together as one sine squared of x. And we know that one sine squared of x is the same thing as cosine squared of x. And then since we have two cosines on top and one on the bottom, we could actually reduce one of them and it became cosine of x. Easy peasy.